Okay, so now that we have our problem here solved, we need to check our answers. And so I've already started that process. So first thing was I know that the number of multiple choice questions and the number of word problems added together is 35. So 29 is the number of multiple choice questions, 6 was the number of word problems, and I add them together to get 35, so that works. Okay, that's the first criteria that had to be met. So the second criteria was this problem that said that there were 2 points per multiple choice question, so 2 times 29, and there were 7 points for each of the word problems, so 7 points times 6 of those word problems should equal a total of 100 points. Well, 2 times 29 is 58, and 7 times 6 is 42, and if I add those two things together, they do equal 100 points, okay? So what I end up with here is 2 equations. I solved them both, found the 2 variables, and I found out that they both work. So final step is to define the answers. And remember, the question up here was how many of each type of question are there? Okay, so there are 29 multiple choice questions and 6 word problems. Okay, and so that's our final answer on this. 29 multiple choice and 6 word problems. Okay, all right. So I apologize for that being a break in the video where we went from solving to checking the answers. I had a student stop by to ask a question, so we're going to go ahead and continue this video. I'm going to flip it over to the back side, and we're going to go ahead and work on a few more practice problems. Okay, so what I've taught you today, okay, a couple of things. Here's some definitions. Systems of equations are 2 or more equations with the same variables. When we solve them, we're looking for solutions that will satisfy both of the conditions that are given in the equations, meaning they have to work in both equations. They can't just work in one of them, okay? So one strategy we use is called the substitution method, which is what we did today, where we found out what one was equal to and we substituted into the other equation to get rid of one of the variables, okay? So it just means that we substitute an equation within another one to find the solution. Okay, so some of these are going to look a little bit easier than what we did. We actually started with a fairly difficult problem so that you can kind of get your feet wet, and now we're going to dive in and do something that's a little simpler and kind of build our confidence. So starting with number 1, we know that y is equal to 4x minus 1, but we also know that y is equal to 2x minus 5. So if y is equal to this, then in place of the y, I can substitute it here. So what I actually end up having is, instead of y, I do 4x minus 1 is equal to 2x minus 5. I substituted a value that I know was equal to y for a y in another equation. Okay, and so I ended up with an equation that looks like this, which is one variable and something that I can solve. So I'm going to go ahead and subtract the 2x here. I'm going to get 2x minus 1, and then I'm going to add 1, and I'm going to move my work over here. Sorry about that. I have 2x is equal to negative 4. I'm going to divide by 2, and I'm going to find that x is equal to negative 2. Okay. All right, so now I know what one of these variables is, so I can take it and plug it back into either one of these inequalities to find the correct answer. So that's what I'm going to do. Y is equal to 4, and instead of x, I'm going to plug in the value negative 2 minus 1. So y is equal to negative 8 minus 1, and if I subtract that, I get negative 9. Okay, and so notice that in these problems, I have an x and I have a y, which should ring some bells, because a lot of times when we're dealing with coordinate points on a graph, and we're dealing with ordered pairs, it's an x and then a y. So you can actually write your final answer as an ordered pair, negative 2, negative 9. Okay, or you can leave it as x is negative 2 and y is equal to negative 9. Either way. All right, so now we just need to check and make sure that both of our criteria have been met. So I'm going to take and plug both of these numbers into both equations. So I'm going to start with y equals 4x minus 1. So y was negative 9, x was negative 2, and then I'm going to solve. That's negative 8 minus 1, which is negative 9, so that one works. And then in the second equation, we have y equals 2x minus 5. Y was again negative 9, x was negative 2, and we subtract 5. 2 times negative 2 is negative 4. And that leaves us with negative 9. Again, so negative 4 minus 5 is negative 9. So yes, both of those numbers work, and we know that this is going to be the two solutions that work for this system of equations. Okay? All right, so we're going to look at another example here. So number 2, we know that y is equal to 6x. We also know that 2x plus 3y is equal to negative 20. Okay, so in this case, I know that y is equal to 6x, so I could take that and plug it in here for y and solve, because I know that y is equal to this, so I can substitute it in the place of the y in the other equation. So that's what I'm going to do. I'm going to do 2x plus 3, and instead of y, I'm going to plug in what I know y to be equal to, which is 6x. Okay? And now I can go ahead and multiply and start moving things around. So 3 times 6x is 18x. 18x and 2x combined is 20x. And then to solve, I divide by 20 and find that x is equal to negative 1. Alright, so now I can take this negative 1 and I can plug it into either equation to find y. So I'm going to plug it into the first one. If x is negative 1, I plug it in, and all I have to do is multiply those two numbers together to find that y is equal to negative 6. So I'm going to take that, and I'm going to check my work. So in the first equation, y equals 6x, I'm going to plug in negative 6 for y, and for x, I'm going to plug in negative 1. And I find that negative 6 is equal to negative 6, so that one works. Then I'm going to do the same thing with the other equation. So write that again. 2x plus 3y is equal to negative 20. So in place of the x, I'm going to plug in negative 1. And in place of y, I'm going to plug in a negative 6. And then I'm going to check to make sure that those work. 2 times negative 1 is negative 2. 3 times negative 6 is negative 18. And if I add that together, I do get negative 20, so that does work. And so my answer ends up being negative 1 and negative 6. X is negative 1, y is negative 6. Remember, always write it x and then y. Okay? All right, so then we move on to another question. So y is equal to x plus 9. So again, we're going to take that value and we're going to substitute it in the place of y. So 3x plus 8, and instead of y, I'm going to use what I know y to be equal to, which is x plus 9. Everything else in the equation stays the same, and I'm using the second equation.
Any faculty that needs their picture made, come to the gym, and any student that was absent on picture day can have theirs made now.
Okay, sorry about that, guys. I had an announcement that I had to listen to. Alright, so let's go ahead and finish this up. So we're going to go ahead and multiply 8 times x, which is 8x, and 8 times 9, which is 72. And then we can simplify. It's 11x. We're going to subtract the 72. And then we end up with 11x is equal to negative 77. And then divide by 11. And so x ends up being negative 7. Okay. Alright, and then from here, we can take this value and plug it back into the original, either equation. So I'm going to plug it into the first one because it's a little bit easier. So instead of x, I'm going to plug in negative 7, and I'm going to add 9. And so y ends up being 2 here. Okay, and so all I need to do is check our answer. So y is equal to x plus 9 was the first equation, and so I'm going to plug in 2 for y and negative 7 for x. I'm going to check to make sure that that works, and it does. Okay, so then I'm going to use the second equation. I have to check both of them. 3x plus 8y is equal to negative 5. So in place of x, I'm going to put negative 7. In place of y, I'm going to put 2, and I'm going to check to make sure that that equals negative 5. So 3 times negative 7 is negative 21. 8 times 2 is 16. And if I add that together, I do get negative 5, so it works. So my final answer on this is negative 7 and 2. Okay, and then we have one more question that we need to work out before we get to the last word problem. So I'm actually going to stop the video here, and then that way we'll work out these last two together in one final video.